Let's go through a couple conceptual questions. Go ahead and read through this. Determine what you think the answer is. All right, let's reason through this. So we have two liquids. We're just increasing their temperatures. So we're going to look and relate Q equals mc delta T. Since they are heated for the same length of time over identical burners, we can assume QA and QB, the Q that they both, the energy they both receive is the same. So we're comparing the mc delta T, essentially. We can say the mass of material A, C, the specific heat of material A, times the delta T, the change in temperature this material goes through, has to equal mc delta T for material B. Oh, but we're told they have equal masses. They have the same initial temperatures, but liquid A is hotter than liquid B at the end. That means delta T for material A is bigger than delta T for material B. If they start at the same initial temperature and material A ends up hotter, it has gone through a bigger change in temperature. Well, if delta T is bigger, then C of A has to be smaller in order to maintain this equality. If temperature B is smaller, then specific heat has to be bigger. So liquid B has the larger specific heat. So specific heat is always related to the amount of energy needed to change the temperature of a 1 kilogram mass of that material by 1 Kelvin. So if we have the same mass and we put in the same energy, a larger specific heat means a smaller change in temperature. All right, let's look at one other question I have for you. Read through this, and what do you think? Okay, the answer is going to be B. So we can say the Q of the silver plus the Q of the water is equal to 0. The energy the silver loses or gives is going to go into the water. We have the same mass in both cases, though. And so similar to the last question, this C and the delta T is what is coming into play when we are dealing with the same mass. Since the specific heat of silver is so small, really, really small compared to that of water, C of water is really big in comparison, then the silver's temperature is going to have to be a lot bigger than the change in temperature of the water in order to maintain this equality, to talk about the energy exchange staying only within the system. So if the silver goes through a much larger change in temperature, it's going to be more than half, and that's why we'll end up closer to 0 than 50. In fact, we could solve it if we want. If we put in the mass of silver, which is 1 kilogram, C of silver, T final, they're coming to a final common temperature. The silver started at 100 degrees Celsius, plus the water is also 1 kilogram, 4190. T final is whatever final temperature the system comes to. We were told that the water is initially at 0, so we can solve for this. We're going to have 234 T final minus 234.00 plus 4190 T final equals 0. So T final would end up being 5.3 degrees Celsius. Very close to 0. Much closer to 0 than 50. But please make sure you're practicing reasoning through this type of stuff conceptually as well. So larger specific heat, it goes through a smaller change in temperature when we're dealing with the same mass and energy.